commercially, but you cannot integrate into product or so. So that's one disadvantage for, let's say, larger companies like ours to adopt it and integrate it into product and become contributor. So we are open source center, but we are limited to a subset of licenses. So for example, we can easily contribute to Apache 2 projects or BSD projects. That's not a problem. But if the license isn't allowing us to also put the software into a product at the end of the day, then we have a hard time to contribute to it. No, we are quite high in the rank of contributing to Kubernetes and Kubeflow, KNative, Istio. I think Istio came partially from IBM even, and also in Jupyter Lab we have a lot of contributions in open source. So you see, we are not only taking, we are also giving. That's I think an important thing when you talk about open source. And now I want to show you two things at the same time, or I try at least. One is the tool Voyager2, which you obviously can just run from the command line in a Docker container. So it's a Docker run, blah, 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 and you're up and running. But then I thought, since this is all self-contained in a Docker image, why don't I show you also how you can use, let's say, a container runtime service in the cloud to provide it to others. So since it's such a cool tool, just provide it to others, or you show others your work on your data set using the tool. That's a little the idea. And yeah, then the thing is, I will just introduce you now to KNative. So I assume you have some background on Docker and Kubernetes. In case you don't, I give you just, let's say, a 1 minute summary. So, or maybe give me 2 or 3 minutes, because there might be some folks in the audience who don't know about Docker and Kubernetes. So for those, we will just spend those 3 minutes. So you obviously know what a virtual machine is. So a virtual machine is emulating a complete hardware stack. And on top of that emulated hardware stack, real operating system is installed, and then you go from there. And you can obviously have on large servers multiple virtual machines. So you are basically sharing the server using virtual machines. So it's a containerization or an encapsulation of your code, your functionality, your stuff into an environment where, at least in theory, nobody else can tamper with. But obviously there's an overhead because you are emulating the hardware. That means that processing needs to be done, and that needs to run somewhere that occupies resources on the CPU, on the main memory, and so on. And also the startup and shutdown isn't instant. No, it needs a couple of seconds up to minutes, depending on the technology and the capabilities of the server, that you get your virtual machine up and running. So you cannot, for example, just start a virtual machine on each HTTP request or so. No, that's impossible. So then the next thing is Docker. Docker basically is a way to simulate the behavior of a virtual machine without actually running a virtual machine. The idea behind it is isolation. So this is implemented in Linux. I don't know whether it's implemented in other operating systems. So if you're using Docker maybe on Windows, not sure. On Mac, you are actually starting a virtual machine in the background. It's just for development only, no, otherwise it makes no sense. But in Linux, actually, there are two main contributions which enabled Docker. One is called C groups and one is called namespaces. So C group stands for control groups, which actually allows to assign a limit to consumed resources to individual operating system processes, for example, number of cores or main memory and so on. And the other thing is namespaces. You can think of namespaces just as some sort of change root environment, but it's not only for the file system, it's also for other things like devices and other resources. And using those two, I mean, you can hack it yourself, but Docker actually gives you a nice command line tool to encapsulate that for you. And then what then happens is a set of processes is encapsulated into a container and running on the operating system as normal processes, but with limitations. So the resource limitations and security and access limitations actually make you think, if you're inside a Docker container, that you are alone on the system, that you are like in a virtual machine. But if you go to the host system and do a PS, you see all the processes running of all Docker containers. But in the Docker container, obviously not. So that gives you a way of containerization, virtualization, if you want, without the need for starting a virtual machine. And that actually allows us to start and stop Docker containers in milliseconds, and not even in seconds or minutes. And that obviously opens a larger set of use cases. So if you have a lot of containers, so I will strip out the word Docker now from my explanation, because it's not only Docker. There are many other container runtime engines, and if you have a lot of containers running on one system or even on a cluster of multiple systems, you need some sort of orchestration. So there was, or there still is, Docker machine and Docker Swarm and Docker Compose and all that stuff. But actually the market leader and the de facto standard now is Kubernetes. So Kubernetes is a container orchestration engine. So it can start and stop containers. But in addition, it will also, let's say, orchestrate or manage, for example, other resources like a network. So the whole networking is also done by Kubernetes. So now you have the capability of starting and stopping containers and manage that completely by Kubernetes. But if you have now an application which isn't doing anything in a specific moment, it's just sitting there and the processes are still idling around, so mainly consuming main memory. So if they're idling around, they're not consuming any CPU cycles or only little, that's not a problem, but they are consuming main memory without serving any purpose. And that's where KNative kicks in. So KNative is some sort of, or basically uses the underlying infrastructure of Kubernetes. There's one term I need to introduce as well. If you are in Kubernetes space, you don't talk necessarily only about containers. You're talking about one more broader entity called a pod, POD. And a pod is basically, you can somehow think of a pod like a Docker installation. So a pod shares the same network interface, for example, and within the pod, multiple containers can run. But then obviously you cannot, for example, in one pod assign the same port, the same TCP port to containers. Just for information, if you stumble around the term pod, so you know what pod is. Okay, so, and those pods usually in Kubernetes are just idling around until they serve a purpose, and then they are just doing what they need to do. Then obviously there are some other mechanisms to scale up and down. That means you can then automatically start new pods if the workload is getting higher, and then also scale down. That's all possible in Kubernetes. But you don't have scale to zero. So scale to zero means if there's no workload, then nothing runs. And that's where KNative kicks in. So KNative will answer to HTTP calls and then decide if there is a container to be started. You obviously can have for example, one container or pod running idle in the background just to make sure that the first guy who hits it will get an answer. But you can also just say, okay, I don't care. I will just scale to zero, and the first guy will just wait for an amount of time. And by the way, the amount of time usually the main part of the cycling up of the container in KNative is how long it takes to actually load the container image from persistent storage or from the cache, or worst case from the internet. No, so just make sure your container image is small if possible. Okay, so if you see this diagram here, you have at the bottom Kubernetes, and then you have KNative, and on the left hand side you will see the developers interacting with KNative using an API / CLI command line tool, which then interacts with the API. That means if you are used to Kubernetes, in Kubernetes you have a command line tool and the API. The command line tool is called kubectl, or KUBECTRL, and that's used to interact with the Kubernetes cluster. just one thing, if you are on OpenShift, OpenShift is the Red Hat commercial Kubernetes distribution. You have a second tool called OC. Don't get confused, but still on OpenShift you can use kubectl anyway. So, but in KNative, this is a different API, as you can see, and there is a KNative client tool as well, which you can use to interact with KNative directly. Then a last thing at the top here is you see Istio. So Istio is a so-called service mesh that allows you, you can consider Istio like a HTTP router. So it will take care of security, SSL endpointing, for example, and also making sure to route a specific request to the correct pod. It's also, so KNative with Istio together will make sure that if the pod, which is in charge serving this specific HTTP request, isn't alive, it will get started by KNative. Okay, so that's the theory, and now let's dive into practice. So what I will show you now here is the, let's say, UI of a tool called CodeEngine. So CodeEngine, as I already said at the beginning, we are taking open source, we are contributing to open source, and we are wrapping open source into products. So CodeEngine is, let's say, the wrapper around KNative, and we call this KNative as a service, and also serverless, because KNative is all about serverless. So in CodeEngine / KNative, you can have applications. And let's actually create a new application. So I have this already prepared, obviously, because it takes some time and I don't want to take the risk this not working. But let's just create such an application from scratch. So so it's important to use proper names, no? That you know that you have deleted afterwards. So you can now create an application from a container image lying around in some repository. So in this case, it's Docker Hub. And you see here, it's taking, it has my name. The reason is I had to fork this project and do a little change, and then repush it to my registry. Otherwise, it won't run in KNative. I have created a PR. I need to double check if that is the pull request to the source repository. I'm not sure whether this is already in or not. But I have just, if you're interested, on my YouTube channel, I have explained what I actually did in detail to make this run in KNative. So it was just one configuration I had to change. So that's the source of the image, where it comes from. You see here also source code is possible. So you don't need to actually provide a ready-made container image. You can also point, for example, to a Git repository, and it will auto-detect the programming language and the framework, or it at least will try, and then create the image for you on the fly. So this is, so you need only three things to put here. It's the name of the application, then the container image location, and then the port. So each container will, which serves like a web application, no, will open a port where HTTP or HTTPS requests will be served. In this case, HTTP, because usually the SSL endpointing is done outside the container. So here you have to tell KNative that actually port 9000 is the one on the container which is serving the HTTP requests. And then Istio will generate a public endpoint, SSL endpoint. And if you hit that endpoint, then Istio will take care of endpointing the SSL connection, or terminating the SSL connection, and via HTTP forward the request to the specific port where this application runs it. So then what we can do in addition is runtime settings. So that's here the number of instances which this application can run in, the minimum and the maximum. So the minimum means 0, in this case scaled to 0. it's only one application. It's nothing running if we don't get any requests in. And then we can tell the maximum number of pods in this case, which are actually started for this application in case it runs out of memory or resources. Then we have also the instance resources. So each instance can have a certain configuration of CPUs and main memory, and we can select from there. And it's pay as you go. No, you just pay for what you consume. That's the idea behind it. And by the way, in CodeEngine, there is a free tier. I don't have the numbers in my head, but it's sufficient to run, I guess, the smallest one 24/7 that actually would allow you to get some sort of a Raspberry Pi style node in the cloud for free. Just and you can run any container in it. It's pretty cool. Yeah. So, and then there's another section where you can post environment variables. For example, if you have any passwords, also the container needs to connect to somewhere also, then you can put them in there. And then command override for the Docker users. This is obvious, no? In the Docker file, you can basically tell the command which has to be run inside the Docker container after it got started, to actually start the application in the container. And then the application needs to block. That's important. It is not allowed to stop, so it needs to block. It needs to continuously run, and also open port and server HTTP endpoint. In this case, this application will do it on port 9000. So you see only 1, 2, 3 parameters which are necessary, and a lot of blah blah which you don't need. And then you say create, and then it will actually deploy the application. You see here it's deploying, and everything I've done here, it's just a one-liner in the KNative command line tooling as well. And you can also use, for example, CodeEngine and connect to it via command line or any KNative environment. So let's actually let this running. We'll come back to that later, because I have already created Voyager2 for you. And I'm wondering why it's showing 0 here, because I just started it. Maybe it already scaled down to 0, then we have to restart it. Yeah, let's see what happens. This is, let's reload, or let's reload on the second tab. So now I will show you Voyager. And as you can see here, it's taking time. That means I was talking too much. And while I have been talking, CodeEngine or /KNative decided, oh, this guy is lazy and not doing anything. We will scale this back to 0 again. So I have now hit it again, the URL, and let's see what happens. So I have one idea. Let's see if you have any questions. Just type questions in the chat box, and we will see if we just take a couple of questions while this is starting. If I don't get questions, I use just the second link and hope that it's still running from the browser cache. So let's see. Oh, okay. We have some problems. Check. Some stream is not working. Okay. Has been fixed, it seems. New subscriber. Thanks a lot. Okay. Yeah, then good idea that I promoted my YouTube channel here. I have a new subscriber. Thank you. Okay. Any other questions, comments, complaints, additions? Okay, cool. So let me just try to reuse the already existing session here. It might not work, then we have to wait. Otherwise, this will show up soon. Now, what happens now in the background? See, I have hit this URL. This URL was generated, or this endpoint name was generated for me by Istio. So you see here, appdomain.cloud. That's everything. If you don't bring your own domain to IBM Cloud, everything will have appdomain.cloud at the end. And then everything within CodeEngine will have CodeEngine.appdomain.cloud. And then here, this is the data center. I'm running this in Frankfurt in Germany. And then this is the project identifier, which is random. And then in the project, I have the different applications, and that's the name I gave the application. So this is how this URL is created. And you see here, it's HTTPS. So although the container in the background is serving a HTTP endpoint, here I have HTTPS security. And now I was just speaking enough to have this loaded. So in the background, if you go back to CodeEngine, you see here Voyager2 has now one instance. And if we would stress test it, we could actually make it scale to up to 10. Anyway, so this is now Voyager2. This is a very, very cool free tool. Open source, but you are not allowed to use it commercially, just as a reminder. And there are pre-built datasets just to learn how it works. Or you can just paste CSV data here, or you can upload a file from your hard drive. The thing is, just be aware, this is running in the browser. So that means don't expect to do big data in here. No, it's a couple of megabytes it can work with. If it's more, then it will crash. Just that's the second limitation. The first limitation is the license and policy, and the second is the data set size. Obviously, you can also run loaded JSON, CSV, or TSV from a URL, but let's actually use a pre-built dataset which the tool provides to you, and let's actually use cars. So it's if you are in R, also in pandas, this dataset is called MT cars. And actually, this is a dataset which is containing cars from US, I guess. And the cars have different properties. For example, the main or the most interesting is miles per gallon, but there's also number of cylinders, horsepower, displacement, weight, year of manufacturing, and so on. And then you can now analyze this data without programming skills. That's the cool thing. It's actually taking some time, so I'm double checking if there are any questions. Otherwise, I use the cached version. Okay, no question at the moment. Let's give it another minute or so. Otherwise, because I don't know what happens if I'm using here the session from before, if it gets an error or not. That's why I just thought I will just wait a little. But actually, we can be brave. Let's actually be brave. So this is the first view. Or I can talk over this view. So this is the first view. Once you have opened the dataset in Voyager2, this is what you get. So what you get is at the left-hand side, you see all the fields in your dataset. So all the, let's say, columns in the table. And it also tries to estimate or guesstimate the type, the data type. And then you have here on this middle panel here, you can drag and drop the fields to different locations here to basically slice and dice through the data set. And what happens here is it gives you already some suggestions on how you could analyze the data, but it will then appear here, whatever you do. Let's see. Okay, I'm a lucky guy. I'm just always talking over my waiting time, and I'm doing good here, no? So let's see. You have here cylinders, as I said. So name is not so important, origin not, but year of manufacturing, cylinders, acceleration, displacement, and so on. So what we, for example, can do is we can drag and drop miles per gallon. Sorry, that was a mistake. I wanted to drag and drop miles per gallon. So you see here miles per gallon. Okay, so the higher, the better. Now you see here we have some sort of a normal distribution. So most of the cars are consuming between 20 and 30 miles per gallon, some more, some less. Now let's add a second dimension. For example, we could say the number of cylinders. And you see here very easily that there is a trend. The more cylinders you have, the more fuel the car consumes. You see here the 8-cylinder car just consumes more. So it's, I would say there's not enough data for 5 cylinders and not for 3, but for 4, 6, and 8, you see some sort of a normal distribution. This is a little skewed with 6 cylinders and 8 as well, but the 4 cylinder is a very, very nice normal distribution. So everything is centered around 30. And then you have here the standard deviation. Same here for 6. So this is a little skewed here towards consuming more. And here, the 8 cylinder, I would say it's a little skewed towards consuming less. So let's actually try to use, for example, horsepower. And we can just play around here. So you see here, let's see if this is any good. Maybe. Give me just 1 second. I think I used weight the last time. Yeah, anyway, it doesn't matter. Let's go back to horsepower. And switch those. Yeah, that was the view I had last time. That is much more clean. It's just and you see it's also swapping. You can drag and drop it and it's swapping here. So this is a much cleaner view because you see here the relationship between miles per gallon. So the more you go to left, the better. Sorry, the more you go to right, the better. And you can clearly see here the sweet spot. If you like go to the best car here, it's even telling you it's the Mazda GLC. It has 4 cylinders and the horsepower is, where's the horsepower? 65, no? So the size of the circle tells you the horsepower, and you see here the more cylinders you get and the more horsepower the car has, it consumes more. Let's actually replace with weight. Weight is maybe also interesting. Where's weight? Here's weight. Let's actually use weight here, and we can try to get back the horsepower in color. So it's now getting maybe a little confusing, but still, if you like concentrate and look at the picture, you have actually drawn just 4 variables into one picture, and that's pretty cool, no? So you see here, the lighter the blue, the less horsepower you have. The smaller the circle, the less the weight. And you see here, obviously, the 8-cylinder cars have a lot of horsepower and a lot of weight and are consuming a lot of fuel. And you see here, the 4-cylinder cars, they are better. Interestingly, the 3-cylinder cars aren't, no? They are also quite consuming a lot. And then you see here, maybe it's because of the weight or it's because of the horsepower. That's how you can exploit. Okay, and you see here at the bottom a lot of pre-built charts for you, and yeah, that's the way. And if you can, if you have time, you can play around with it. So let's actually see here a different data set. That's the iris data set. So the iris data set is basically giving you data about 3 different types of flowers. And again, here you see some recommendations of charts, but you see here, species is the name. Then you have of the flower 4 properties, and then you can just visualize this as well. So for example, let's take species on the y-axis, on the x-axis. So we have 3 species here only. And then let's see here the distribution of one of the properties of the flower. And you see here, it's interesting to see if you, for example, want to create a classifier. You see here, it's very, very easy to already classify Setosa versus the other two species by just having a boundary here between 2 and 3. No, that's very easy, but it's more complicated to distinguish between the other two types because they are overlapping. And then you can just add other properties here. That's not working out. You see, let's see this here. It's also not working out. It's overlapping. And let's see this here. Also not. So the best one to start with is this one here. And then you can try around with other properties and see whether this multi-dimensional view of data changes anything. No. So you have here, for example, the size or the color or maybe even the shape. So the shape is actually not usable in that context because you have just too many different values. The shape you would use for categorical features, for example. Okay. Yeah, that's actually it. Let's see what happened with the other deployment. You see here, it's ready. It has 0 instances, and we open the URL, and then we just go to QA. And after that, we go back and see if this instance already is up and running, which we are currently starting here. And you can see here the URL changes. So it's all running maybe behind the same IP, but through the host name and the URL, we are distinguishing, Istio is distinguishing between the applications and then routing the requests to the correct pod. Okay, so are there any questions? Questions from Tony. You developed to CodeEngine, but are there other ways to deploy Voyager? Of course, yeah. Voyager2 you can install like from a, I would say Python package. Let's double check. Voyager2. So how I started is I used the Docker image. So you can run the, it's hard to find, huh? The correct Voyager data visualization. The most easy one is obviously Docker. Here it is. So this is actually the homepage of Voyager2. Oh, sorry, no, this is a demo. This one. So Washington University. So this is the official homepage of Voyager2. And then if you go to code, then let's double check which is the correct repository. Not so sure about that. I would say this one here. And then there should be some installation. Is there some installation? Installation. Okay, you can use Yarn. So I would argue it's a Node.js application. Yeah, it's a Node.js application. Yeah. You can use Yarn if you are familiar with that, but I'm not so a JavaScript expert, so I was a little intimidated. So I just thought it's maybe easier to just search for the Docker image. And then if you say Voyager2 Docker, you should, yeah, here it is, Docker image. And I think they even give you the command. Here's the command. Let's actually just run it on my machine that you see how easy that is. So we just pull this. Is that correct? Is that all we need? Docker run port, blah, blah. Yeah, I would say that's all. So it's now pulling the data from remote. I hope my connection and audio is still there. And let's see how long that takes. If you wait, yeah, maybe we wait. Let's take another question in parallel. Where are you? Where are you? I lost you. Here you are. Okay. So then second question from Tony. Have you hit any limits with the data sets you have analyzed? Oh yeah, I have. I don't remember the size, but it was a relatively small data set. I would say around 120 megabytes or so. I mean, in terms of number of rows, it's obviously a lot. It's millions of rows. So this was actually causing my browser to freeze. So as I already said, the two limitations are the license is a little restrictive, and you can double check the license. And the second is the dataset size. Where is the Voyager homepage? I lost it again. Anyway, to go back here. Is there a license? Obviously on Git, there should be a license. And the license is proprietary to this institution here. And so this is fine, no? Redistributions have to have the source code. This is also fine. Okay. It's not that restrictive. I thought it was more restrictive. Anyway, that's okay. I mean, I would have to check with IBM Legal if we want to use that in a product and contribute to that, but actually we can check that. Yeah, that's the thing. And the other limitation, obviously, is the dataset size. Okay, so any other? No. So no more questions? Do you have any questions? Just ping it in the chat. Okay, all the questions. So we can go back to CodeEngine and see. No, to this one if it's ready. No, it's not that one. That one? No, where are you? Where are you? Here it is. See here? So demo delete me, and then I can just here. Let's take the iris dataset because I know it's small. Or what I can do is I just can load a large data set, but then you will see it's just freezing. So that's not a good idea because then also the live stream is freezing. Yeah, that was it from my side. If I don't receive anything else, I'm done. Thanks a lot for joining, and I hope you learned a little thing about KNative and Voyager2.
Well, thanks very much, Romeo. It was a great discussion. Really interesting to see how you could leverage the CodeEngine to be able to implement an application and pull it together and run it. And it also looked like that the functionality of Voyager2 was pretty good in doing the analysis of the data. So once again, thank you for coming out and sharing with us. I would also like to thank everybody that was watching. We appreciate you coming out each week to watch episodes of Let's Code. I will remind you that next week we will be moving this channel to 10 a.m. Eastern Time. So Let's Code will happen at 10 a.m. Eastern Time on March 17th. And we'll be having a discussion and demonstration of the IBM Developer Technology Sandbox. So please mark your calendars and come out and watch that episode. With that, I'm going to once again thank Romeo, and we will see you next week.